This video will go over writing quadratic equations given the vertex and a point from the graph. In order to solve these, you need to have vertex form memorized, and you also need to remember that your vertex is the opposite of h and k, so you can pull your vertex straight from your formula. Let's look at a couple examples of this. If I give you the equation 3 times x minus 2 squared plus 5, and if I ask you to name the vertex, your vertex would be positive 2, positive 5. Remember, it's always opposite of what's in the parentheses, and then whatever is outside of the parentheses. The minus 2 means we've moved right 2. That's why we have positive 2 for the h. And then the plus 5 means we've moved up 5, giving us a positive 5 for the k. Go ahead and pause the video, try to name the vertex for 2, 3, and 4, and then restart once you're ready to check. For number 2, your vertex should be negative 2, negative 1. For number 3, your vertex is negative 3, positive 1. Be careful with your signs. And then for number 4, my vertex is positive 1, negative 8. Now we're going to use this to come up with the whole equation. So the first one we have is vertex 1, 0, and the point is 4, 9. You're always going to want to start by writing out your vertex form equation. Now, your vertex is always going to stand for h and k. Your point is always going to stand for x and y. What we're solving for here is the a value. So if you remember from our previous lesson when we wrote equations from a graph, we found a by looking at the pattern and by comparing it to our parent function. If you didn't like looking for the pattern, you can always use this method as well. You can take your vertex and you can take a point to solve for a. Here's what that's going to look like. I am going to plug in 9 for y. I don't know what a is. My x is 4. My h is 1. And my k is 0. We are trying to get a by itself. So I'm going to start with my parentheses. 4 minus 1 is 3. The following order of operations here. 3 squared is 9. And you can write that as 9a. That's what you're more used to. Now, you can bring down the plus 0, but plus 0 really isn't going to change anything. So really, you can forget about the plus 0. Now, all I have left to do is to divide 9 on both sides, and I get 1 for a. Your final answer needs to be an equation, and it's going to look something like this. Y equals, plugging in 1 for a, plugging in 1 for h, plugging in 0 for k. You're always going to plug in values for a, h, and k. You could also write this equation as just x minus 1 squared, because the 1 in front and the 0 really aren't going to change anything. Either option here would work. Let's look at another one. This time I've given you a vertex of negative 5, 2 and a point of negative 2, 11. So plugging this in, I have h, k, x, and y, which means I'm plugging in 11 for y. I don't know what a is. X is negative 2. Be careful with your signs here. You're plugging in negative 5 for h. Well, minus a negative 5 is going to change that to negative 2 plus 5. Negative 2 plus 5 is positive 3. 3 squared is 9, so I can write this as 9a plus 2. To get a by itself, first I'm going to subtract 2 on both sides. Then I'm going to divide by 9. So A is 1. Your final answer here is y equals 1 times x plus 5 squared plus 2. Or, since A is 1, you can always just write it as x plus 5 squared plus 2. Those mean the same thing. Since we are just writing our equation here, your final answer is not going to have numbers written for y and x. You're going to leave those as y equals x plus 5 squared plus 2. At this point, go ahead and pause the video, try this one on your own, and restart once you're ready to check. To solve this problem, I'm first going to write out my formula. I have my h, my k, my x, and my y. Plugging in 8 for y. I don't know what a is. X is 1, h is 2, and k is 5. From here, 1 minus 2 is negative 1, and negative 1 squared makes this positive 1a. From here, I subtract the 5 on both sides, and I get 3. If you divide both sides by 1, your a value is just 3. So my final answer here is y equals 3 times x minus 2 squared plus 5. Alright, for this next one, same method. I'm going to write out my formula. I have h, k, x, and y. We have to be super careful with our signs on this one. My y value is 2. I don't know what a is. My x value is negative 5. And I'm plugging in negative 3 for h. Be careful, this becomes negative 5 plus 3 in the parentheses. Well, negative 5 plus 3 is negative 2. And negative 2 squared is positive 4. I can write that as 4a. From here, I'm going to add 6 on both sides. Divide by 4. And what I just found is that a is 2. A is 2 is not my final answer, though. My answer has to be an equation. So I plug in a, I plug in h, and I plug in k, making this my final answer. You may also see these written as tables, and really the process is the exact same. It's just going to look a little different because instead of just giving us the vertex and a point, you're now given a set of points on a table. Your first step is to figure out what your vertex is. And remember, with quadratics, they are always symmetric around your vertex. So if you look at this table carefully, you can see that I am symmetric around 5, 3 because I have 4, 4, 6, 4, 7, 7, and 3, 7. Those y values are symmetric around 5, 3. What that means is this 5, 3 here is my vertex, my h, and my k. Then you can pick any point to be your x and y. You could pick 3, 7, you could pick 4, 4, 6, 4, or 7, 7. Each point will give you the same value for a. I'm just going to pick 3, 7 because it's first. But really, you can pick any of them. So I'm going to plug this in just like I did all of the other problems. I have 7 for y. I don't know what a is. I have 3 for x. I have 5 for h. And I have 3 for k. 3 minus 5 is negative 2. And negative 2 squared is positive 4. That becomes positive 4a. To solve for a, I'm going to subtract 3 on both sides. And then I'm going to divide the 4. So my a value on this problem is 1. A equals 1 is not my final answer though. I need the equation y equals 1 times x minus 5 squared plus 3. You could also write this as just x minus 5 squared plus 3. Those two mean the same thing. Let's look at another table example. On this table, you can see that I am symmetric around the point 4, 1. Because I then have negative 1, negative 1, negative 7, negative 7. So I am going to use 4, 1 as my vertex, h and k. And then you can pick any point to be x and y. Again, I'm just going to pick the first one. Plugging this in, my y is negative 7. I don't know what a is. My x is 2. My h is 4. And my k is 1. So to solve for a, 2 minus 4 is negative 2. Negative 2 squared is positive 4, so I can write that as 4a. I subtract the 1 on both sides, and I get negative 8. Then when I divide by 4, my a value is negative 2. My final answer is y equals negative 2 times x minus 4 squared plus 1. Remember, your final answer should have a value for a, h, and k. Go ahead and pause the video, try this last table on your own, and then restart once you're ready to check. For this last table, my vertex is the negative 3, negative 4. So I'm going to use that as h and k. And then you can pick any point to be your x and y. I personally am going to actually pick 1, 4 here because it's two positive numbers. You can pick any point though, they should all give you the same answer. So plugging this in, my y is 4. I don't know what a is. My x is 1. My h is negative 3. And my k is negative 4. Be careful. When you plug in negative 3, that becomes 1 plus 3. You have to be super careful with your signs. Well, 1 plus 3 is 4. And 4 squared makes that 16a. From here, I add the 4 on both sides to get 8. And when I divide the 16 over, 8 over 16 is going to reduce to 1/2. Your final answer should be y equals 1/2 times x plus 3 squared minus 4. If you think back to our transformations, the 1/2 means that this graph is going to be wider than our parent function. It's going to be a vertical compression. That's it for writing equations in vertex form from a vertex and a point. Remember, you can use this method whenever you're dealing with graphs as well. If you prefer to not look for a pattern, you can always plug in a point and a vertex and check for your a value. If I ask you for the standard form of an equation, you can always do this method first and then FOIL out your answer, distribute, and then add at the end to convert it to standard form. Remember, there's that video that we previously watched on converting vertex to standard form if you need it.